So we have three questions A, B, C, which is actually easy. So first is solving using the cyclic redundancy check. The data was 1001. The divisor is 1011. So it's there in this textbook picture over here. So see, I have solved it like one by one. What happens if it is 1? You will take as 1 line to 1. If it is 0, all are 0. If it is 1, the same thing will come here. If it is 0, all are zeros. Whole subtraction 1 minus 1. You simply and write the positive values. That's it. Then you will get this code word. Again, code word is shift change. Instead of this, put the code and again run. You will get triple zeros. That's your answer for that. Okay. So then comes your second S frame. So what is S frame? Under HDCL, you have three types of frame. Those are I frame, S frame, and U frame. Under S frame, it is one of the types of HDCL used for flow control and error handling. See flag, address, control, FCS, and flag. So these numbers are bytes, number of bytes. So you can simply mention in each explanation in each field. So flag is nothing but starting and ending value will be described from it. Boundaries of the address contains the address of the repeat instance where it has to go. Destination address. Control, so it controls the flow control and error control by specific control informations to manage that. It will use that in the it's mentioned over here. It has sequence numbering and acknowledgement request. So FCS is nothing but frame check sequence used for error detection. FCS is like CRC value to the frame to check for errors. Okay, flag closing, same one word, same as opening flag. It marks the end of the frame and shows the entire frame is processed. Explanation of each field. See, just read this once. You should be able to understand. I have explained it properly, right? So, what is the difference between allow and slotted allow? See here. First of all, time division. Here, no synchronization time ka no division is there, but here it is divided into slots. Transmission what? We are transmitted any time, but it is transmitted at the it must wait for its time slot and transmit at that time. Collision, it is higher and is lower. Efficiency less, it is more because of higher collision, less because of lower collision, more. Slot duration, no slot duration because follow that, but it has slot duration. Performance, it is poorer and it is better. So these key differences, conclusions and key points. So we'll move on to the next question. What is a bit-oriented framing and its frame pattern? Explain the example byte stuffing and unstuffing in a bit-oriented framing. So definition, let's move on to the definition. In bit-oriented framing, uses sequence of bits to represent data and control information. So what bit-oriented is what? It uses bits to represent the data. Okay. And in this method, data is transmitted as a continuous stream of bits, where frames are identified by special bit pattern rather than character. So here, data is transmitted continuously in the form of bits as identified by the bit patterns, not by any other things. So frame pattern, a common frame pattern in a bit-oriented framing is the everywhere you will be having this flag of 8 bits starting with 0 and ending with 0. In middle all are ones, also known as the 0x7e in hexadecimal. So see again it has flag, address, control, data, FCS and flag. So additional thing is data over. So everything is same, right? If you want to explain, you can simply explain here. Data is nothing but contains the actual message. That's it. Nothing else is changing. Control also all the same thing. Byte stuffing definition. In bit-oriented protocol, when the data contains the same bit pattern as the flag, special are needed to prevent confusion. So byte stuffing, also called as character stuffing, involves adding a special escape character before a byte that matters. So you have to show the diagram for that, which should come somewhere around here. You can use this example. Okay, so okay, it comes here, right? Is it real? Okay. So here, see, byte stuffing and unstuffing. This is the diagram. So original data is 1 6 times 1 0 6 times 1 0 flag sequence within data after. So what happens? So see here, 1 is 0 and 1 is 1. Here 1 is the escape character after the flag sequence. And while what happens? So to prevent this confusion, this has happened. This changes has happened. Then unstuffing again, this changes will be changed. So see, receiving data is like this. After unstuffing, again it becomes to the actual data. Explain the flow diagram of CSMS/CD and explain. So CSM, so diagram, this you have to again go and see that video itself. Diagram I can provide you with it, but it's not actually that good. But you will be getting the diagrams in the community channel, so you can follow the community channel of what to say our YouTube channel. So example, see this is this diagram which is not clear, which will be sent in the community channel. You can just go and visit it. So what is the PPP? Is nothing but point-to-point protocol. What are the services? So why not we just highlight these points: connection, authentication, transmission, encryption, and commission services. Oh, just a small diagram. So and the question it asked for 6 marks. So what are the services? Link and establishment and configuration. PPP establishes, configures, and tests the data link connection. It supports multiple authentication protocols such as PAP, password authentication protocol, and CHCP, challenge handshake authentication protocol, and three of the devices like Google Meets. Error detection, it uses CRC or for error detections to ensure data integrity during transmission. Compression, we compress data to increase the efficiency of the link. Multi-protocol support. We can encapsulate protocols allowing different networks protocol to be sent over the same link. It's nothing but what to say. Acknowledgements are the data is divided, like not divided. The data is acknowledged in like that. One concept was there. Network layer protocol negotiation. PVP allows the negotiation of network layer protocols, IP or IPX. So see, encapsulate multiple protocols, allowing different network protocols to be sent over the same link. So one link is for one protocol. So here for PPA, versatile protocol that offers link configuration, authentication, error detection, point-to-point connections. So you have to remember these 6 services. Since the marks was 6 marks, so one definition and 6 points. Establishment, you just remember by link establishment. See, configure and test the data link connection. Authentication is nothing but challenge handshake or password authentication. Compression was it compresses the data for increasing the efficiency. Multi-protocol support, what is in a link itself, it is for carrying multiple protocol. As network layer protocol negotiation. PIVA allows the negotiation of network layer protocols such as IP, Internet Protocol, and IP Internet X. I don't know what is X stands for. You can comment down. So that's all for completing this module with all the videos. So we'll move on to the next module, module 3 in the next video. Till then, just keep liking and subscribing this channel and show some support.